Otherwise, we're going to get started. Okay. So we got our warm-up question here. And just getting my calculator ready. Okay. So we're going to start off with a little bit of a throwback from some of the stuff we learned already. So let's solve for some unknown angles in this triangle. Well, first off, we know that this is 90 degrees, and we have a right angle triangle here, and we want to solve for the other two angles. So all we have to do really is solve for one of them, and the last one will be pretty easy. So let's solve for this one right here. I'm going to call that one theta. All right, so we want to know what that one is equal to. But before we do that, we have to take care of these things here, because those are measurements, but they're not measurements that help us. We need to convert those first. So let's convert those. So if we have 3 feet and 2 inches, now there are 12 inches in every single foot, right? So we should really be doing this by going like this. 3 times 12 plus those 2 inches. Right? So 3 times 12, we have 36 inches plus the other 2. So we end up with 38 inches. All right, so that's one measurement done. And we have to do the other one on the other side over there. So let's look over here. 2'5". So same thing, 2 feet times 12 inches plus our 5 inches. All right, so this is 24 plus 5 gives us 29 inches. All right, so once we have that, so we know this is 29 inches, and the other one's 38 inches. So now we have our two sides. And then we have to start labeling everything. So we need to label it relative to which side is which. So now that we have all the measurements, let's label them. So the longest side is always our hypotenuse. And then directly opposite side, right there, here's our opposite. And that leaves our last side, our adjacent. All right, so we have to use what we know. So what do we know? Well, we know the adjacent side, and we know the hypotenuse. So we have to use a trig function that uses adjacent and hypotenuse. So let's rewrite out our term. So ka toa. All right, so we're looking at our letters, and we're trying to figure out which one uses adjacent and hypotenuse. And we find that it is ka. There's the one we want. All right, so let's use that one. So cosine of theta is equal to A over H. Now let's put our values in. So for A, we had what, 29? Yeah, 29 inches over 38 inches. All right, and that's going to give us a ratio. So we'll do 29 divided by 38. And I'm getting, we just want we want the number to 3 decimal places. So I'm getting 0.763. All right, so there's our number. But we're not done yet, because we need to figure out what the angle is. So the angle, to figure that out, we're going to use that cosine with the -1 thing there. So that's your second function, cosine. And then a bracket comes up, and you're going to put that same number in again. And then we're going to find our answer, and we're going to round it to the nearest degree. So 0.763. And I got an answer of 40 degrees. All right. All right, so we end up with 40 degrees. So this here is 40 degrees, and that means this last part is the easy one, because all we have to do to figure out this last one is go 180 minus 90 minus 40 equals. So 180 minus 90 is 90. 90 minus 40 leaves us with 50 degrees. So there's our last answer. One angle there, one angle there, one angle there. All right, we've got all three angles, and let's move on. Let's refresh from last lesson. So we're solving for a point of intersection. Now, if you recall again, right, we have step one. Which was to let equation 1 equal equation 2, right? Because we have this one right here, and it's going to be equal to this part right here. So let's write that out. So we end up with 3x minus 2 is equal to negative 4x plus 5, right? So there's my right-sided, or equation 2 right there. Here's equation 1 right here. Okay, so they're both equal to each other. And then we can solve for x. So we need to get all the x's on one side, and we have to get all the numbers on the other side. So let's do that next then. I'll switch my pen to make it a little bit smaller here. Okay, I'm going to put all my x's to the left side, because that way they're going to end up all being positive. So I'm going to get rid of this one right here. So I have negative 4x, and it's going to get added to 4x. So whatever I do to one side, I have to do the other side. So I end up with 3x plus 4x. Oh, 3x plus 4x, let's just do that. We'll do that math first. 7x minus 2 is equal to, and remember these ones we're going to cancel out. So positive 5. All right, now I just have to get rid of that minus 2. On that left side. So I will add 2, and whatever I do to one side, I must do to the other side. So I end up with 7x equals 7. And these ones cancel each other out. All right, so now I've eliminated all the numbers. I've separated them to all the sides. I just have to get rid of the number attached to the x value. And to be able to do that, they're being multiplied, so I need to do the opposite, which is dividing. And when I do that, these will cancel out. And on the other side, they kind of cancel out too, because 7 divided by 7, how many times does 7 go into 7? Once. There's our value. X equals 1. All right, so now that we're at this point, we've got an x value. So now we need to find a y value. All right, so to find the y value, we substitute in x value into either equation. Right? So, for example, again, this is equation 1. And here's equation 2. Let's pick equation 2 this time. So I'll do y is equal to negative 4 plus 5. And the value we're substituting in is 1. So we end up with y equals negative 4 times 1, which is negative 4, plus 5. So y equals 1. There we go. So we have our point. So we finish off by going therefore the point of intersection is 1, 1. All right, so we found the point of intersection. Easy. Now, today's lesson is taking the same thing, except that one was pretty easy because they are in the form of y equals mx plus b. But sometimes that isn't always the case. Sometimes we're given equations that are not in that exact form. And we have to rearrange it first before we can find the point of intersection. So all we're doing today is adding on an extra step. How do we rearrange our equation? So let's look at that. So for example, in this one right here, it is not in the form of y equals mx plus b. So we must put it in the form. So our first step is put in the form of y equals mx plus b. All right, so to do that, we need to get our y. We want to get this guy over to that side, right? And as I've told you before, anytime something switches sides, all we're really doing is changing the sign. So if this is a negative 6y here, it becomes a positive 6y on this side, which we can just write as 6y. Now the 9 is still there, and let's go like that. All right, so we have 6y plus 9 equals 12x. Now we need to get rid of the plus 9 now. We want to get it to the other side. So this becomes 6y equals 12x minus 9. So again, when it switches sides, it just switches signs. All right, so now we're almost there. We just have to do the last part, which is we need to get rid of that 6. So we need to get rid of that 6. So we're going to divide everything by 6. Every term is going to be divided by 6. All right, and so 6 divided by 6, they cancel each other out. So that becomes y equals 12 divided by 6. How many times does 6 go into 12? Twice. And then negative 9 over 6. Negative 9 over 6 is just negative 3 over 2. It's the same thing. Or negative 1.5, either way. So there is our rearranged equation. So that's the first step we need to do, is rearrange this. So anytime we have points of intersection, that's not always going to be in the y equals mx plus b, so we just need to rearrange it first. Let's try a couple more examples. Let's look at this one here. I'll use the other notation this time. Okay, so all right, I want to get my y equals. I'll put it on the left side. So I'm going to get rid of the one on the right side. So whatever I do to one side, it must happen to the other side. So these two will cancel each other out. Right? So my new equation looks like this. And now I want to get rid of the 8x. So let's do that next. So if I have plus 8x, I'm going to subtract 8x. Now, like I said, you could just move the symbol over there. You don't have to show this notation that I'm showing. I'm just doing it just to show you different ways of doing it or writing it. So I end up like this. Negative 4y equals, and I can go like this, negative 8x plus 24. Okay, last step. Let's get rid of those negative 4's. So we're going to divide every term by negative 4. And we end up with y equals, because these will cancel, so y equals negative 8 divided by negative 4 is 2. So we have 2x. And then the last part is 24 divided by negative 4. So one of them is negative. So we end up with a a negative number, right? Positive number divided by a negative gives you a negative number. And 24 divided by 4 is 6. So that is our equation. So that 8x equals 4y plus 24, that's the same thing as the one on the bottom. All right, I'll do one last one. Actually, let's see here. Yeah, I'm going to show another one here. Let's do the one with the decimal. Okay, so this time I have the y and the x on the right side. So this is easy because, again, if this goes over to that side, it just becomes positive. So 2.5y plus 7.5 is equal to 10x. And now I want to get rid of the 7.5 and make it go to that side. So I end up with 2.5y equals 10x minus 7.5. And the last thing is dividing by 2.5. So straight across the board, we're going to divide by 2.5. And we get y equals, just like that. Now, I'll do one last example because I want to show you that you actually don't need to leave the y on the left side. I could have left the y on the right side because sometimes it's more convenient. It's not really in this case, but I'll show it anyway. So let's say if I have negative y over here, let's just get rid of this term and put it to that side. So I end up with 8x minus 12 is equal to negative y. So all I have to do is get rid of this negative y number, which is negative 1. The number attached to the y. So there's a negative 1 there. So I'm going to divide everything by negative 1. And I end up with, so 8 divided by negative 1 is negative 8x. Negative 12 divided by negative 1, they're both negative, so I get a positive number. So I get negative 8x plus 12 equals y. Or, it's the same thing as saying this. These two are the same. All right. The last one's pretty easy. Here, all you have to do is, again, look at this. What do they have all in common? They're all divisible by the number 5. Anytime you have a situation where it's either a 0 or 5, you can tell that they're divisible by 5. So we could just go right across the board, divide by 5, and you have y is equal to 3x plus 20. Sorry, not 20. My bad, 16. There we go. Okay, so we've done all the examples there. There's a couple more that you can do those ones. So you can try these ones. And now let's use it to solve for a point of intersection. So this is kind of just a longer question. We just, the points of intersection, all we're doing is adding that extra step. So we'll do it first. So let's look at our question here. So this one right there, this one's already in y equals mx plus b format. But this one here, we need to rearrange. So let's rearrange that one first. I'm going to rewrite it off to the left side. So I have 6x equals negative 2y plus 10. All right, let's rearrange it. I'm going to put the y on the left side, so I end up with 2y plus 6x equals 10. And I want to get rid of the 6x, so 2y equals negative 6x plus 10. And let's divide everything by 2. So I get y equals negative 3x plus 5. All right, so that is my equation 2. And here we have equation 1. So our next step is let equation 1 equal equation 2. Right, because y equals y. So let's rewrite it. I have negative 2x plus 4 is equal to negative 3x plus 5. All right, and now we're going to start collecting our x's on one side. So I'll do it this way this time. Plus 3x plus 3x. So I end up with 1x plus 4 is equal to 5 because these cancel. And then I want to get rid of that 4, so I end up with 1x equals 5 minus 4, which is 1. And we're going to divide by 1. You really didn't necessarily need to divide by 1. You could probably just eyeball that and realize that x equals 1. But I decided to do it anyway. All right, so now that we have an x, value, solve for y. So we're going to do that up over here by substituting in that value of x into either equation. It doesn't matter which one. So let's go like this. Y equals negative 3x plus 5. Y equals negative 3 times 1. All right, so there we are. We have our y value now. So therefore, the point of intersection is 1, 2. There's our coordinates. So that's where those two lines meet. So that's all we're doing today, is taking the thing that we've already spent 2 days looking at and then adding just an extra step in front. So before you make the equations equal to each other, you must make them so they're in the form of y equals something, because we need to make it so y equals y. All right, let's do another example here. Again, break it down step by step. So make sure both questions are in the form of y equals mx plus b. All right, and so that we can see that this one is not. So we need to rearrange that one. So let's do that first. So I'm going to rewrite it on the left side. 6x minus 3y plus 12 equals 0. So don't be worried about that 0. 0 is just kind of holding an empty spot on the right side of the equal sign. So we want to make it so we have y equals something, right? So let's get rid of the other things. Let's get this and make it go to that side. Let's get this and make it go to that side. So we end up with negative 3y is equal to negative 6x minus 12. And then we just want to get rid of those negative 3's. So we need to divide every single number by negative 3. So I end up with y equals 2x plus 4. So there's my equation 2. All right, so now that I have equation 1 and I have equation 2, set the equations equal to one another. That's what we're doing next. Set the equations equal to one another. Okay, so I have equation 1, let's write it out, 5x plus 1 is equal to equation 2, which is 2x plus 4. All right, so now we're just going to solve it like we did before. So let's get rid of the x's and we'll put them all on the left side. So we can subtract here, and whatever we do to one side, we have to do the other side. So we end up with 3x plus 1 is equal to 4. And then I want to get rid of that 1. I'm going to put all the numbers on the right side. So let's get rid of it there. And there we go. And we end up with 3x equals 3. And then our last part is divide by whatever number's attached to x. X equals 1. All right, we've solved for x. So once we do that, again, we do our second part, which is solve for y. And we enter the same value of x into either equation. Let's pick this one this time. Y equals 2x plus 4. Y equals 2 times 1 plus 4. Y equals 6. Now again, if you use the other equation, it wouldn't make a difference. You get the exact same y value. And then we can wrap it up by saying, therefore, the point of intersection is 1, 6. All right, and that is it. So on your quiz, which I'm about to post, I haven't put it up yet, I'm just still finishing the last couple questions, there are questions like this. So I have 2 extra practice questions for you to do, right? This one here and this one here. If you have questions about this, please send me a message, but otherwise it's pretty much the same as we've been doing for the past 2 lessons. You just need to practice it. And if you're finding you're struggling with it, I can help you walk through it, but it's more about practice than anything. And that's it for today. Are there any questions? I see Bella and George and Ty, so I'm going to assume not a lot of questions. Everyone's mic is muted, which is fine.